Is it on? So, as I was saying, this talk went through a number of titles, and I feel like a bit of a fraud because I have absolutely nothing to do with Brogue whatsoever. But it's a roguelike talk, so I needed some sort of roguelike game in the title, and I wanted some buzzwords as well, so I put web scale. And I typed B-Rogue and web scale into Google, and I got an entry from Wikipedia about spiders, and spiders' red eyes pierce the darkness, and so do enemies. Anyway, so what I'm going to be talking about today is basically presenting some research I've done over the last week or two that was interesting to me, and I hope it's interesting to you guys as well. The industry I've been working in at the moment is sort of obsessed with software as a service, infrastructure as a service, platform as a service. What does all this mean? Well, broadly in the old days, you used to buy a computer, buy some software, you might put the software on your computer and use it. That's the old model, and we're getting rid of that. Nowadays, you just rent the ability to run software on my server, and I charge you by the day or hour or second. So, can we do this with Brogue? Can we make Brogue as a service? Or Brass? Okie dokie. So, before I actually go on to that, I'll tell you a little bit about myself. I've written a number of 7-day RLs, starting with DD Rogue in 2009, which was meant to have sort of DDR-like dance moves, special moves in it. I then moved on to Princess RL, which was sort of vaguely Princess Maker-themed kitchen sink roguelike. I took a couple of years off to write a commercial game on Android called Dungeon Ascendants. Then I returned to ASCII with Flatline RL, which was Hotline Miami themed, not themed, inspired, sneak around behind robots and throw knives at them kind of game. And then 2014 I wrote Trauma RL, which was the first game to use an algorithm I've been developing to build multi-stage procedural quests, look at the connectivity graph of the rooms in the dungeon and sort of intelligently place quest objectives. And I threw all that complexity away for this year's 7-day RL, which is a sort of one-room, big guns, badass, sort of arena killer game. So please check it out. So, Brogue is a fine game made by a gentleman called Brian Walker. I'm sure most people have played it. It's very similar in concept to the original Rogue. It's just got lots and lots of cool features. And it's better balanced. So let's return to my first buzzword, web scale. What do I mean by web scale? Well, I mean a game that's playable via a web browser. And I'm talking about a game that's sort of running on a server. So it's capable of serving a large number of simultaneous players. And the kind of functionality you might expect is to observe other people's games. Maybe global high scores, high scores of a day, high scores of a week, that kind of thing. So I had a hunt around games which sort of fall into this category. And the games I'm really looking at here again are ones which are mainly running on the server side. So you've got NetHack at out.org. You telnet to a server, it's running an altered version of NetHack. You can play online, you can look at other people's games, and you've got Java and Flash applets on the web, which basically allow you to telnet. Probably the best example is Cruel Web Tiles. This is hosted there. It's a graphical interface in your web browser. Again, the game itself is running on a remote server, and what it's sending to you is just what to display. Okay? And this is a really fine piece of software. You can observe and chat. And it uses a technology called Websockets, which I'll talk about in just a sec. So, where's Brogue fit into this? Well, a very clever gentleman called Kip Raske, which I've probably not pronounced correctly, announced an online version of Brogue back in March. There's a link to the forum post there. Unfortunately, he then took it down. He had something better to do with his server. But the source code is hosted on GitHub, that link there. So I've been just trying to understand the source code, understand how it works over the last couple of weeks. That's why I'm presenting here today. And I believe it's architecturally similar to the way Cruel with its web tiles works. And he did a great job with the online version of Brogue, and it is built to support a lot of these crawl-like features, observing, chat, etc., although those aren't currently in the code base. So here I'm going to try and explain a little bit about how my understanding of the web-brogue project works. So here's your web browser, and it's running the web-brogue interface. The first thing your web browser does, it says to the web server, hey, get me all of this sort of graphics and the thin amount of JavaScript you need on the client side to run things. So you use a protocol called HTTP, and it just says get index. Basically, the server replies with all the stuff you see here. When you actually want to start playing the game, it moves over to using a different protocol, which again I'll talk about in a sec, called Websockets. And everything you do from there on, whether you're signing in, whether you're actually playing the game, is handled over this sort of new protocol. On the web server side, you've got a program that actually sort of deals with the web-facing part, is written in a language called Node.js, which is a server-side version of JavaScript. How does Brogue get involved in this? Well, it's very simple, actually. This system runs one copy of Brogue for every player who's logged in a separate directory on the server. So basically, again, all of the game is happening on the server side. All the web browser is doing is saying, hey, I pressed left, I pressed right, and this big blue blob here is sending basically what the web browser should render in terms of what's on the screen. And I'll go through these bits one by one in a sec. There's also a database for storing usernames and passwords. So what's this WebSockets thing? Well, the web normally uses a protocol called HTTP, and it's a sort of one-shot request-response style system. So your web browser, go to Google or something, just say, get me the index page. The web server goes, yep, there you go. There's the HTML that represents that. I'm done. When you click on the link, again, even to the same server, you'll start up a new connection to the server, you'll go and get a different page. That works fine for most web applications, but when we're doing a web-based game, it's not really very good. There's a lot of overhead. Every time we want to do an interaction, we need to start a new connection to the server. And there's no way of the server sort of pushing stuff to us. The only way it would work is if you said, hey server, is something going on? It would say no or yes. With a WebSockets protocol, you've got a long-lived connection, so you don't have the overhead every time you interact with the server. And you can do bidirectional communication. So the server can push to the client. You can imagine the game being updated due to somebody else perhaps playing, and getting that stuff pushed down to all the clients without needing to poll for it. There's some disadvantages to the protocol. Some networks, because it's quite a new protocol, don't carry it. So occasionally you'll find it just doesn't work on mobile platforms, for example, or on mobile networks. And it's not very cacheable, which is perfectly fine for games, but it's probably why you wouldn't want to write the whole web using WebSockets. And again, it's a bit new, so there's limited library support when you're developing with it. So let's look at how the Brogue system works with this web server. Well, Brogue, again, is a very well-written game, and it strongly isolates its input and output to basically a particular file. Brogue already supports curses, which is a console output library from the 80s, and libgcod, which is a handy roguelike library from about 10 years ago. To make it work with the web, what Kip has done is basically put in a new plugin file, if you like, which has the web equivalents of plotting a character, of getting the next key press or mouse event. And that means basically the web end of Brogue can be written as another rendering target. Which is, the advantage of this is, you're not making a whole heap of changes to the VROgue source. So when Brogue is updated, your changes are probably going to be limited to that file, and there's going to be very little work to move over to a new version of the executable. Which is handy if the person writing the web front end isn't the same person who's writing the actual game. So just to go into that into a tiny bit more detail, as I described before, you've got your web browser here. When you click a button or click your mouse or press a button, it sends a message over to the API. The API then takes that message and passes it to the web-brogue that's running your directory, and does that over 2 channels, which are called standard in and standard out. If you've used any sort of Linux or command line apps, you're probably familiar with standard in and standard out. It's standard ways of getting your data in and out, normally text in and out of programs. What it does mean is that all the screen updates are coming out over standard out, and they're coming out as little text messages. Those get then translated by the browser in a way I'll show you into the actual screen. Okay, so you've got key presses and mouse messages coming in here, and you've got basically cell-by-cell screen updates going out the other way. And just to show it's true, here's an example of the messages. As I can say, probably the most interesting one is the screen updates. Whereas web-brogue normally renders to a screen, what it's actually doing now is sending a whole heap of messages like this. Update 6012 on the screen with a character for an S, do it in red, and do it with a blue background. Okay. Likewise, when the input events are coming in, they're sent to web-brogue in a format like this. It's a mouse click, it's a 4020, it's just being held. So how do those messages actually turn into something you'll see on your web browser? Well, the way it's being done is fairly straightforward. This is a screenshot of the browser interface. Every square here is an HTML div. You've got a bit of information about obviously the font size, the color, and literally this plus here is a plus in HTML. So it's not using HTML canvas, it's actually using sort of base HTML here, which is universal but can be a bit slow on some platforms. So just looking at the architecture as it is and thinking about how we could take this a little bit further, unfortunately the project's being abandoned, but I'm kind of looking for something to work on, so this is at the top of my mind. One problem with this architecture is when the server crashes or is taken down for an upgrade, it kills all games in progress. At best, you have to rely on web-brogue saving the state out and then loading a game. My experience of web-brogue save mechanism is it isn't great, so it'd be nice to get around that. The next thing is, the way it's been written is to run on a single server. As we heard in the previous talk, if you get hundreds or thousands of simultaneous users, which may be unlikely, you'll need to bring in multiple servers, but you still want users to go to, for example, one URL. So how can we achieve that? So the first thing we need to do in order to fix the crashing problem, in my opinion, is to get away from using the standard in and standard out communication mechanism between the API and the web-brogue program. The problem is when the API, let's say, crashes or is taken down for an upgrade, it either kills off web-brogue or it loses these connections and it can never get them back. So there's a couple of ways around this. One I'm suggesting here is to use something called Unix data ground sockets. So this is a bit like an intra-server UDP, if anyone's familiar with network programming. The idea is you have what looks like a file alongside your web-brogue client in the directory. By opening that file, the server can communicate with the program, with web-brogue, and that will stick around even if the API crashes. When the API starts up again, let's say after an upgrade, it just scans all the directories that it knows about and can reopen the connection. So this means effectively, as I say, if I was developing this, I could throw up a new version and everyone might have to reload, but that's the worst. Games would still be running. So for the final part, I wanted to talk about scaling up. So probably the most relevant question is, how far would you need to scale an online web-brogue system? Crawl's a popular game, and I looked at the Crawl web tile server and has about 50 concurrent users. And Brogue's probably not quite as popular as Crawl, so probably 50 concurrents is a useful thing to work to. However, for the purpose of this talk, I wanted to be a bit more optimistic, and let's say 1,000 concurrent users, as an example. And if you, in the business I'm working at the moment, we have TV ads, and if you have a TV ad, you can expect a massive spike of users. So imagine there's a TV ad for Brogue. I surreptitiously slipped a URL into one of our adverts that you get this at. Then you could imagine a sudden spike of users. But if we're looking at that scaling, we ought to be looking at the CPU, memory, and bandwidth usage. So for this little bit of modeling, I considered a single user running on Auto Explore about 50% of the time. And a single user uses about 10% of one core running Auto Explore, my server. So 50 users would work on an 8-core machine, about 60% utilization. In terms of memory, the sort of base processors use about 100 megs, and Brogue can use about 8. So 50 users would be about 500 megs. So neither of these things look too unreasonable for a 50-user pattern. Bandwidth is a bit different. Because you're sending all the screen updates over the wire, the bandwidth is quite considerable. A user doing Auto Explore can use 25 kilobytes a second, which doesn't sound a lot compared to video, and it isn't, but if you're thinking about actually hosting this yourself, it's considerable. This is a moon, so in a month, the user's playing Brogue continuously, that's 60 gigs. 50 users takes it up to about 3 terabytes. It sounds kind of scary, but if you look at hosting plans, you're looking for a server that could run for 50 users, you're looking at about $160 a month, and these are quite conservative estimates. You can probably get away with less than that. And on my hosting, $5 a month, you can probably quite easily run with 10. So finally, I thought I'd put my server-side engineer hat on and talk about scaling up to 1,000 concurrent users. So don't want to dwell on this too much, but let's say we have all our users coming to brogue.com or another roguelike.com, because the principles here are pretty similar. You run them first of all through something called a reverse proxy, which simply divides the traffic that's coming in to a number of different APIs. You have an API here that's responsible, in my model, for a particular user, allocating him to a particular back-end game server, and remembering where he went. Obviously, if he was to come back in a day, you want to pick up the same session he left. Okay? You use this WebSockets, that's terminated here, and we use a conventional networking protocol, just TCP sockets, between the front end and the back end. So, again, that's my little model for how one could scale a WebTiles-style game up to a load of users. What really needs doing? Not really that. This project is open source, and certainly I encourage anyone who's interested to contribute. Now the original author has left. There's things they need: cookies for credential stores, global high scores, observer mode, and chat. Some of these features, although not significant, do require minor changes to a web-brogue executable, which, as I say, is something you want to minimize if Brian is continuing to update it. Okay, so those are my conclusions. I think in terms of a WebTiles style product, Brogue is already a very good first start, Brogue Web rather. With minor changes, up to 50 concurrent users can be served, and scaling any of these projects like Crawl or like Brogue up to 1,000 users is possible, and I've proposed a design, but immediate work is really required on the feature set rather than scaling up to more roguelike players than there are in the world. Okay, thanks obviously to all the guys who did all the coding that I've just been trying to explain today, and for Mark and for you all. Thanks very much. If anyone would like to actually have a go, I'm hosting it, so you can probably get myself to break on roguelikelive.com 1881. Yeah, roguelikelive.com 1881.
When did you buy that domain?
After you suggested somebody should buy that domain. Hello. You doing?
Yeah. I'm just wondering whether you were talking about bandwidth considerations. How realistic would it be to use something like mscripten to run it on the client side? Because I know, for example, that Internet Archive used it to run main and a lot of like console and arcade emulators in JavaScript, is like inside the web page. These are all like written in C, in SQL, whatever. You just compile it with mscript into JavaScript and run it on the client.
Okay, I've never heard of that. Sounds quite likely because the Brogue source is pretty standard C. The reason not to run it on client side is particularly if you want to do competitions or like a weekly competition or high scores, you don't really want to trust the client. And as soon as the code runs on client side, then obviously you're in a situation where the server just has to trust what the potentially modified client says. So I like the server-side model. The bandwidth is a problem, but becoming less so with time. And additionally, the reason it uses a lot of bandwidth is because auto-explore shows every frame. So if I go flick over to my web browser, you can see, again, it probably depends on this is running on the web, on the server.
You can't see anything.
Can you? Oh. Okay, so why is that not come up on here?
We can try that on the big screen as well.
Okay, well, anyway, the main bandwidth usage is auto-explore showing every frame, which is a nice user experience. But if you look at the way Crawl does it, it just shows you a beginning and end frame with auto-exploring. So a model like that would really save bandwidth.
Only if you set that in your config.
Okay.
You have to actually change it to just simple auto-explore.
That, certainly in the WebTiles version, it seems to do it for me by default.
Yeah, we changed it to do that by default on WebTiles. It's actually the same.
No, that's interesting. I'm playing on a laptop, it works fine on mine.
It's like a couple of seconds there.
I just killed a jackal.
Yeah.
Well played.
And on that note,